If you are given an exam and you are supposed to define wavelength, amplitude, and diffraction, this is how you are going to go about it. For this question, we are told that the progressive wave, state what is meant by wavelength. We're going to say that wavelength is the distance between it's the distance between two successive crests or troughs. For amplitude, remember a wave oscillate from the mean position, and then we're going to define amplitude as the maximum displacement of the wave from the mean position, how far a wave moves up. For instance, if this is a transverse wave, this part section here is the amplitude, and the distance between two adjacent crests is going to give us our wavelength. For you to get wavelength from this type of graph, it must be a displacement distance graph. But if it was a displacement time graph, the distance between two successive crests or troughs is going to give you a period of the wave. So you have to be very careful what you are given on the x-axis. Now moving down to diffraction, we're going to say that diffraction is the spreading of a wave as it passes through a gap or as it passes around an obstacle. As we can be able to see in this simulation, this wave is passing through the gap, so it's going to spread out. So let us write now what we mean by diffraction. We're going to say that is the spreading of a wave as it passes through a gap. Next, we need also to look at coherent waves. We're going to say these are waves which have a constant phase difference. So you can be given question to do with diffraction grating, and remember diffraction grating works in the principle of superposition. And then if you're given a diagram like this, you can see the angle that is given is between the two third order maximums. So we are going to say a half of 68 is 34, and this part is also 34. Then since this is the third order, n is going to be 3, and we are given the wavelength. Then we're going to see, to calculate the separation distance, we're going to use this formula, Bragg's equation. And remember, Bragg's equation was first derived by L.W. Bragg, who was a British physicist, and he had won a Nobel Prize in 1915 together with his father. So this is the time in 1915, and he had derived this equation to enable find either wavelength or the number of orders. So n is the number of order, lambda is the wavelength, d is between adjacent slits of the grating, and theta is the angle between the maxima from the central. Yeah, so we're going to rearrange this formula so that we can be able to write it in this format, and then we can see here we have the order, we have the wavelength, and in this case our wavelength is 650 nanometer, so we have to convert it to meters by multiplying by 10 raised to power -9, and then divide by sine 34. Working it out, you are going to get your answer as 3.5 times 10 raised to power -6 angle. Now look at we are moving the wavelength, we are changing the wavelength from red to blue, so meaning we are decreasing the wavelength. If you decrease the wavelength, the angle becomes smaller, the angle decreases. But if you are increasing the wavelength by moving to the red section, the angle increases. So for this diffraction grating, the increase of wavelength increases the angle. Also decrease of the wavelength, you are decreasing the size of the angle. So we are going to say the angle will be smaller because wavelength has reduced, and we are also going to say that shorter wavelength produces smaller angles. between the maxima.